Hey everybody. What you notice on the screen today is we're just going to talk really quick about some system material, specifically something that you might refer to as like special cases. So I want to jump into maybe some quirkier situations. Here we go. So you take a look on the screen and you can see the problem that we're asked to deal with. What value of k gives a system with infinitely many solutions? And there's your system, so we can talk about it properly. There is equation 1, and there's equation 2. So you need to come up with the value of k so that that system would have infinitely many solutions. Okay, let's steal some problem-solving practice right now. Pause the video and try to go through and solve that one on your own. Okay, pause it now. Okay, we're back. So I am hoping when you see that orange underline part, infinitely many solutions, that brings to mind to you that what we're talking about are the same lines. Now, the reason why I'm referring straight to lines is because you can take a look at equation 1 and equation 2, and because your exponents on your x and your y are both 1, we know that those are lines. And so if those lines, the system that they include, has infinitely many solutions, that means that those lines have to cross infinitely many times, therefore they are the same line. Okay, how could you tackle this? Well, I'm going to give you a little advice, and this is just going to be to make a problem universal. By no means do you have to do this in this problem. But to make it universal, what I might do is write the equations in the same form. For instance, take a look at equation 1. Do you notice how we start with our y term, then our x term, then our constant? Everything is on one side of the equal sign. You can see the equal 0. Well, what we could do is take equation 2 and do the same thing. So what I'm going to do is I'm going to take equation 2 and I'm going to write it in the same order. My 4y term first, my y term first, then my x term. So notice my kx term is on the other side of the equal sign. I want to get it in the same order as equation 1, so to get rid of a plus kx, I'm going to minus kx. My 4 is on the same side of the equal sign. That now equals 0 because everything's on one side. And what you can see then is equation 1 and the new version of equation 2, the gold one, are written in the same order. Now, all I'm going to do is just zoom in on that for a second to see, there's my y term. Look at the very top and the very bottom. There's my x term. There is my constant. Okay, why is that useful to me? Because if I know that those equations are supposed to represent the same line, to have infinitely many solutions, then I know that those lines have to be equal. They just look different. So I may take a look at the beginning, and all I'm going to do to make sure that we don't lose focus is I'm going to cross out the original version of equation 2. So we can focus in on the two equations you can see. What you might say to yourself then is, well, what did I do to equation 1 to turn it into equation 2? How did I change it? Remember, they look different. And I'm hoping we can see that that looks like we multiplied by 4. Okay. Well, if they are the same line and we multiplied one term by 4, then we would have to multiply all terms by 4. Let's do a quick check on the constant. Yep, 1 times 4 is 4. So what that tells me then is the number out in front of that x must also have been multiplied by 4 to give you the number out in front of that x. So if I zoom back out, that allows me to draw the conclusion then that therefore -2 times 4 has to give me -k. You'll notice the x's aren't there because we're talking about the coefficient on x, the number out in front of x. And what that does is allow me to solve a very straightforward equation. There's my k value of 8. Nice. There we go. Hopefully not too bad. That is a way that we can deal with solving that equation. If we recognize infinitely many solutions, we can then say, hey, we know that they're the same line. So how do we change one to the other? My recommendation to you was the gold. Write your equations in the same order. Now, I'm going to really quickly go, you didn't have to deal with it that way. Like for some of us, we may have taken equation 1 and we would have wanted to rearrange that and maybe write it in a useful form where we can see slope and intercept. Notice if I do that with equation 1, then I want to do the same thing with equation 2. So what I'm going to do then is get my y term all by itself. That means I have to get rid of a plus 4. I'm going to minus 4. Then I have to divide out my 4 to get my y all by itself. To divide by 4, I got to divide the whole right side by 4. Okay, take a peek again. Notice both of my equations start with y. I have a little confirmation. They both have the same y-intercept of -1. If these are supposed to be the same line, then they also need the same slope. And so that slope of 2 that I do know has to be the same as that slope of k over 4. And maybe what you do then is you say, well, therefore, 2 has to be the same thing as k over 4. And now to solve that equation, to get rid of a divide by 4, you need to multiply by 4, and there we go. Okay, 2 ways to go through that, but notice they all start with the same thing. What does infinitely many solutions mean? And then get your equation in the same form. Okay, let's jump into the next one. Okay, I want you to take a look at problem 2. What value of k gives a system with no solution? And there is your system. Ooh, some uglier equations. So I think you are prepared to be able to try this one on your own. Okay, again, give it a shot. Pause the video now. Okay, we're back. So I am hoping that at the very beginning, you would have said, hey, let's get our equations in the same form. Okay, well, to do that, I don't know, maybe we went through and we said, let's write it in slope-intercept. So we took equation 1 and we chose to rewrite that equation divide out your 2. You can now read your slope and your y-intercept. Maybe then you did the same thing with equation 2. That just means that you have to divide out this weird thing of like k plus 2. Okay, there is my second equation. Now, for no solution to occur, that means that our lines do not cross. So we had to remember that that means parallel lines. And what do we know about parallel lines? Same slope, different position, so different y-intercept. Okay, let's take a look back at equation 1. Well, we can see the slope of equation 1. Its slope is 1/2. So we know that if our system has no solution, then the other line also has to have a slope of 1/2. And that can allow you to say, there's my therefore, I'm drawing a conclusion, that my 1/2 has to equal my 3 divided by k plus 2. Okay, you take a look at that equation you just built, and we got a little extra work involved. Look where your variable is. It's on the bottom. So to get rid of that variable on the bottom, we need to multiply it out. So to get rid of a divide by k plus 2, we're going to have to multiply by k plus 2. At the same time, though, I think what that means is we probably want to get rid of this divide by 2, so we're going to multiply by 2. And we can eliminate both fractions at the same time. That gets us to that equation, which is super easy for us to solve. Our k equals 4. Okay, we did the first part. Same slope. But now we need to confirm that we're going to get a different y-intercept. So I have to do a check. And now I'm going to sub that k value of 4 back into my y-intercept. So when I replace that, you can see I've replaced my k with a 4, and now I'm going to simplify. That's going to give me 4 over 6, and that reduces to 2/3. And what I'm confirming is, look back on equation 1. My y-intercept was -1. My y-intercept on equation 2 is different. I don't even care what it is. It's just different. Therefore, I've satisfied it. So all I'm going to do is just box it in to make sure you are good. There is your final solution, our k value of 4. Okay, I am hoping that that helps you through some of those special cases. You know, the ideas of infinitely many solutions versus no solution. Okay, like normal, your job, jump in, knock out some practice. Okay, best of luck.